Hello, grade 9s. This lesson is the first lesson in linear relations, something that you're going to become really quite familiar with. We're going to start out with a little bit of review, and we're going to use equations to describe and solve some problems involving patterns. I haven't placed a video link here, but the video link will come up after we finish this. So in grade 7, we use expressions to decide patterns. For example, here's one we did in grade 7. So you'll see we have one triangle here, and when you take a look from here to here, this is the base of the triangle. So one triangle has a base of 1. But if you move over and put two bases together, you'll notice that in order to create the big triangle, I now have to have 1, 2, 3, 4 triangles. So for a base of 2, I have 4. So we have over here, you see 1, 2, 3 bases. I have to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you go down to our table here and you fill it in, when there was a base of 1, we had one triangle. When we had a base of 2, 1, 2, then we had to have 4 triangles. When our base was 3, then we had to have 9 triangles. Now if you continue doing this, that's our goal is to extend the actual pattern, and then we have to come up with the relationship that we can use to create the equation that we want. So if you take a look at the next one, 4, you'd have to almost draw it out, or if you've already seen the actual relationship, then you'd be able to figure out that 4 would be 16 triangles. So we went from base 1 to 1 triangle, base 2 to 4 triangles, a base of 3 to 9 triangles, and a base of 4 to 16. So by now, you've probably figured out that what we're doing is we're going 1 times 1, 2 times 2, 3 times 3, and 4 times 4. So when you ask what is the relationship between the length of the base and the number of the triangles, what we're doing is we're multiplying the length of the base by itself, and that gives us the number of triangles. So if we want to continue past this, and you had a base of 5, then to figure out what was here on the number of triangles, you'd have to take 5 and multiply it by itself. So we now know that our triangles are going to be equal to the base times the base. We can also rewrite this, taking away the base times the base, because this is actually the same base. We could say that the triangle is equal to the base squared. So I want you to take and change this here into an equation that can be used to model this table up here. So pause the recording and see if you can create the equation. All right, now, first things, before you can create an equation, you have to have some variables. So what I'm going to be doing is I'm going to be taking and I'm going to let the base be a capital B. All right, and I know that we're going to have base times base, or base squared. That means that the base variable b will actually be b squared. And I'm going to let the letter t represent the triangles. So I know that t has to equal base squared. So there's my equation. T is equal to b squared. Now, this is good. We've got it figured out. Now we can ask some questions about it. So, how many triangles would you get if you had a base of 7? Now, the reason we want you to start working with the equation is a 7, you could probably go back and you could figure out from the table how it goes on by patterns. But if you didn't realize what the equation was, how are you going to figure out how many triangles would be there if you had a base of 49, right, or a base of 60? You have to know the equation. So again, here's our equation. Remember, whenever you're asked to do something like this, you have to do the equation. You substitute, which means that the 7 is the base, right? Because it says a base of 7, so that means the base is 7. And now you work out what 7 squared or 7 times 7 is. And of course, that's 49. So if I had a base of 7, that means I would get 49 triangles. Let's go on to the next example. At a wedding reception, tables and chairs can be set up in the following pattern. Create a table to show the number of tables and chairs. Well, I've got tables and I've got chairs, so we're basing the number of chairs on the number of tables because we're changing the tables. So if I have one table, you can see I have 1, 2, 3, 4 chairs. If I had 2 tables, you'll notice I have 1, 2, 3, 4, 5, 6 chairs. Note that 2 tables isn't just 4 times 2, because when you put these two parts of the table together, the seat that used to be for this side and that side are no longer available. So you can't have a seat in here. So we're actually decreasing the seating by 2 in this case. All right? But I still get the 6. Now for 3 tables, I see 1, 2, 3, 4, 5, 6, 7, 8. All right. Now what I want you to do is I want you to see if you can figure out 4 tables. So pause the recording and try the 4 tables. Let's see how many chairs there are. Okay. Well, if you could have just extended the pattern, 4, 6, 8, and you would have seen that this would be a 10. You could have gone up here and drawn the 4th one on a piece of paper and counted it up. But what we need to do now is to figure out what kind of an equation we can have. So I'm going to start out with having the number of tables is going to be n, and the number of chairs is going to be my c. So now I need to figure out what I use the table number, the n here, when I have an n of 1, how did I get to 4? All right. Well, I told you before that when you see what this is increasing by, that's your multiplier. So this increases by 2. Well, because it increases by 2, that means our first part of this equation is going to be 2n. All right? Now, if I had 1, this would be 2 onto 1, which would leave me with 2. Now, we know that there's something else that has to happen because I didn't get 2n equaling 2, I got 2n equaling 4. So how do I get this 2 and turn it into a 4? Well, to do that, I've got to add 2 more. So this becomes 2n plus 2. Now let's double check the next one. If I have 2 tables, then this would be 2 times, I'll just write over top of this, 2. And 2 times 2 is 4. And 4 plus 2 is 6. So you can see that if I had 2 tables, I have 6 chairs. So this one here, 2 times 3 is 6, plus 2 is 8. 2 times 4 is 8, plus 2 is 10. So we now know what our relationship is going to be. The number of chairs is related to twice the number of tables plus 2. So now we do a little bit of mathematics here. How many people can sit, I guess, at a row of 10 tables? I want you to pause the recording and I want you to come up with the answers for these 2 questions. If you want to see a group of 15, how many tables will you need? So pause the recording and try that. Okay, well, for 10 tables, that's pretty straightforward, right? We know that we've got 2n plus 2, and we know that we have 10 tables. This is going to be 2 times 10 plus 2. So that makes 2 times 10 is 20 plus 2. That means we have 22. Now we know that the chairs, this is equal to what the chairs is going to have, or how many chairs we want. So we can see that the number of chairs comes out to be 22. Now, what if I want to go the other way here? Right? What if I want to go and see how many tables will I need if I have 15 people? Well, what I'm going to do here is I'm going to take the equation, c is equal to 2n plus 2, and I'm going to take out the c, because that's, sorry, I'm going to take out the t. Let's see if I got this right here, okay? I'm going to take, I need 15 chairs for 15 people. I'm going to have to take the c and put a 15 in its place. Now here's where your grade 8 algebra comes in place. I want you to take a couple of seconds, pause the recording, and I want you to solve this equation, and then if you don't get it, I will do it for you. So pause the recording. All right, now, to undo an equation, we always have to go in reverse order of operations. So order of operations normally is BEDMAS, but now we're going to do it backwards. So we need to add or subtract first to get rid of this. Well, to get rid of a 2, we have to subtract 2. So remember that we have to have the same thing happen on both sides. So 15 take away 2 is equal to 2n plus 2 and minus 2. Now this becomes 0. We still have the 2n, but over here 15 take away 2 is 13. All right. Now this is just going to disappear. So now we have 2n equals 13. So in order to get rid of the 2, I've got to divide both sides by 2 to keep my equality. So these cancel, leave me with 1n left over. And this here, 13 divided by 2, is 6.5. So if you take a look right now, I need to have n. I get things all mixed up here. I should have an equal sign right there. Okay, there we go. It's hard to do this with the mouse. So we now have n, and we have 6.5. Now you can't have half a chair, or sorry, half a table, right? Remember, n is the number of tables up here. You can't have half a table. And if I round down to 6, I won't be able to seat all 15 people. So I'm going to have to round this up to 7, and I'm going to have a couple of extra chairs available. Okay, turning the page. Okay, let's look at the next example. Sometimes you're not going to be given a diagram or some figures to work from. You're going to be given a series of numbers, or what we call a sequence. Now, the sequence we're given in this example is 3, 4, 5, 6. Now, those are the terms that we are given. All right, so that would mean the term 3, 4, 5, 6 are down here. Now, the term number is the order that they come in. So, for example, the term number for n here, this is the first number, and it's a 3. So the term number identifies what order the term is in. So this is the first number, second number, third number, fourth, and fifth, etc. Okay, so what expression can you use to determine these sequence of numbers? So the question is, how do you get from 1 to 3, 2 to 4, 3 to 5, 4 to 6, and 5 to 7? Now, it doesn't take much to determine that we're actually just increasing by 2 each time. Now, if I want to make this into an expression is going to have to use variables. Now, I'm given the term number, n, and the term itself is t. Now, it asks for an expression here, so it doesn't ask for an equation. So for the first part, I'm not going to have the t in it. I'm just going to be working with the n. So each term is 2 more than the term number, right? So this is 2 more than that, right? So if you let the term number be represented by n, then the sequence as an expression is n plus 2. Now let's take and use this expression. It says, what is the 9th term? So again, we're going to go over here and we're going to progress until we get to the 9th term. And it wants to know what the 9th term is going to be if you have the term number of 9. So what is the 9th term? You got to read carefully. It's asking for the term. What is the 9th term, right? So to go from here down to there, we know that in order to get our term, we have to take the number, term number, and add 2 to it. So this is 9. Adding 2 would mean this would have to be 11. All right, so the 9th term is 9 increased by 2, which is 11. So the next question is, what term is the number 203? Okay, so what term here down below, what term is the number 203? So if that's the case, we know that we have, and I'm going to change this into a formula for us to work with, because now we can use t and n, right? So we know that t is equal to n plus 2. And it says here, what term, so I'm trying to find the term, is the 203rd number. So n is 203. So t is going to be equal to 203 plus 2. So t, in this case, is going to be equal to 205. Right? And that's just what this says right here. So we now know what the term is for the 203rd number. So if I want to write an equation for this, I've already given you the t and the n plus 2 here. So this is your t is equal to n plus 2. This is the equation. Remember, an equation has 2 sides, left and a right side. They have to balance with an equal sign. All right, so let's take a look at our next example. NASA is replacing the shuttlecraft for travel into space. A replacement aircraft is being tested for landing. Similar to the shuttlecraft, it glides down from space to land. One experimental high-altitude aircraft is gliding into a landing. Below is a chart of the speed of the aircraft. So you can see here that they're going to start to come down from outer space. So when they leave orbit, right here, this is when they leave orbit and they start the timer. All right, so it's going to go at 0 seconds. They're traveling at a speed of 10,000 kilometers per hour. Now, as the seconds tick by, it's going to enter the atmosphere, and it's eventually going to come down in speed. So it says write an expression for the speed of the aircraft. Now, this is a little bit more difficult than what we've done before, but I think you might be able to get it. So take a look at 0 to 10,000. 1 to 9750, 2 to 9500, 3, etc. Now I want you to pause the recording and I want you to come up with a relationship that will get you from the time to its speed. Okay, so pause the recording and do that right now. All right, well, if you look carefully, you'll notice that what we're doing here is we're decreasing by 250 every single second. All right, 250 seconds. Sorry, 250 kilometers per hour decrease every second. So what that means is we start with 10,000 and we're going to decrease by 250 kilometers per hour for every minute that goes by. I said seconds, but I meant minute. Okay, so here's my equation. 1,000, sorry, expression. 1,000, 10, that should be 10,000, not 1,000. This is 10,000, take away 250 for every minute that goes by. So write an equation for the speed of the craft. So this is going to be 10,000 minus 250t. So my t in this case is going to be my time, and my s is my speed. So now we have our equation. The speed is the result of 10,000 kilometers per hour decreased by 250 kilometers per hour for every minute that goes by. Okay, let's go to the next page. So the question is, how many seconds will it take for the aircraft to reach half its speed? Well, we know it is traveling initially at 10,000 kilometers per second, right? So at 10,000 kilometers per second, we're going to take our formula, and we have speed is equal to 10,000 kilometers per, I said second again, didn't I? 10,000 kilometers per minute. We're going to take and decrease 250 for every minute that passes. Now, I want its speed to reach half of what it started at. It started at 10,000. So that means that I want my speed, I need to find out how long it's going to take for this 10,000 to get to 5,000. So here's my equation. 5,000 equals 10,000 minus 250t. And I need to solve for t. Order of operations means we have to get rid of the added or subtracted item first. So we're going to subtract 10,000 from both sides. By doing that, 10,000 take away 10,000 is going to become a 0. But you got to be careful here. Don't drop this negative 250. Remember that you take away 10,000, take away 10,000, right? This here, this becomes 0 minus 250t, all right? So this here is a number. Don't drop that negative, right? Now over here, 5,000, take away 10,000, well, you have actually got a greater negative than a positive, so you're going to be in the negative numbers. So now we're down to negative 5,000 is equal to negative 250t. Now to get rid of the negative 250, we divide both sides by negative 250. And of course, this becomes 1, or just t, and 5,000 divided by 250, and negative divided by negative, well, the negative divided by negative is actually going to be a positive, and then 5,000 divided by 250 is 20. So it's going to take 20 minutes, right? Now, I know that I wrote down here how many seconds, but I think I'm just going to stick with 20 minutes in this example here. All right, I'm not going to have us do the calculations because this was a typo here. This was supposed to be minutes, and this was supposed to be minutes here too. All right, so it's going to take 20 minutes for it to actually reach half its speed. Now the second part of this question is how long will it take it to land? So how many minutes will it take it to land? So starting at 10,000 feet again. So here's our equation. Now, if it's going to land when its speed reaches 0. So now my speed has to become a 0. So I need now to find out what the t is, but now I have a speed of 0 equal to 10,000 minus 250t. So to get rid of the 10,000, again, we're going to subtract 10,000 from both sides. 0 take away 10,000. Don't forget that this is a negative number here. So that's negative 10,000, and this here becomes 0, and it still leaves me with negative 250t. Now, to get rid of the negative 250t, I have to divide both sides by negative 250. Okay, and of course this becomes 1, and t is 40 minutes. So it's going to take 40 minutes for the experimental craft to actually come to a stop on the ground. And I'm pretty certain down here I probably wrote seconds again, didn't I? Yeah, I did. All right, so this is minutes. All right. Now, let's go to our next example. In Bob's DJ service, he charges $800 plus $5 per student who enters the dance. Now, I don't know how familiar you are with DJ services, but when they come in, you have to pay them to set everything up. right? And then what happens is there's a charge per student. Now, if they just charge by student and 3 people showed up for the dance, they'd only get $15, right? And they would have set up all that equipment and driven approximately how many kilometers to the school or the location and basically lost their money. So what they do here is they have what's called a setup cost. And in terms of mathematics equation, this here is referred to as a fixed cost. It's there regardless of whatever happens to the numbers of students who enter. The number of students who enter, this is the thing that's going to vary. All right, so this is your variable. I can't write with the mouse very well. Variable, and this is your fixed cost and variable cost. So now create an equation for this. Well, I'm going to start out with the beginning with a cost, a total cost, and I'm going to make this here 800 is by itself. It's always there regardless of what happens, and it's $5 per every student. So I'm going to let the student actually be the letter N. So here's my equation. C is equal to 800 plus 5N. Now I want you to find out how much it will cost for 250 students to come to the dance. So pause the recording and figure out how much it costs for 250 students. Okay, so first thing we need to always do in this case is put down our equation. Now we have to decide, is the 250 students, is that the variable C? Or is the 250 students the variable N? All right, now we went up here, the variable for students, it's the one that changes by $5. So if 1 student comes in, they get 5. If 2 students come in, they get 10. So this is my variable, and this is the only part of the equation that can change. So that makes it the variable cost. The 800 is fixed. So if 250 students come in, that means N is 250. So now I have to calculate it out. So C is equal to 800 plus 5 times 250. Our first step is to 5 times 250. That is 1,250. And now combining 800 and 1250 gives you a total of 250. So in this situation, it's going to cost $2,500 for 250 students to come to the dance. Now, if the student council has budgeted only $1,500, now this is a new part of a new example, okay? Then how many students can come? So they said to the DJ, okay, we only have $1,500 for our dance. And the DJ can then say, okay, fine, I'll come in, I'll set up and then you can let in this number of students. So what you need to tell me is what number of students can come if they only have a budget of $1,500. All right, so stop the recording and figure this out. Okay, well, we start always with our formula. Our equation. The cost is equal to $800, our fixed cost, plus 5 times the number of students, our variable cost. We want to know if our total cost is $1,500, that's our C, how many students, N, can you find? So we have to take and solve for N. Well, we have to get rid of the $800 first. It's fixed. So 800 take away 800 is our first step. If I do it on the right-hand side, I've also got to do it on the left-hand side. So 800 take away 800 is going to give me 0. So my right is going to be left with 5N. And over here, 1,500 take away 800 is 700. So now I've got 700 is equal to 5N. Now to get rid of the 5, I've got to take and divide both sides by 5. And this will become 1N or just N. And 700 divided by 5 is 140. So that means that if they only have $1,500 for their budget, you can only have 140 students come to the dance. Okay. Now, some of the ones here is difficult to do because it says, what is the value of t when x is 15? All right, and they do tell you what the formula is. They're going to give it to you, so there you go. So what is the value of t when x is 15? And they're just going to present the formula to you or the equation to you. Now, if t is what you're trying to find, because that's the question, what is the value of t? We know t is our unknown, and it wants to know what is the value of t when the x is a 15. So there's our formula. And of course we know that formula, next comes substitution. And 5 times 15 is 75. So 120 take away 75 is 45. Now in your notes you'll see me go like this, FSA. Don't forget this, okay? Formula, substitution, answer. You'll also see that almost all of those questions are worth 3 marks. All right, so don't forget. Formula, equation goes down first. Then you put your substitution step in right here. And then your answer. So these are the 3 things that are going to be evaluated. 1, 2, 3. Okay, so let's get the assignment done, and we'll see you in 4.2.